Engineering Progress Measurement Guidelines. Objective: define guidelines for measuring the progress of engineering and design activities, including procurement and construction support during project execution. Applicability: applicable to all projects undertaken, requiring adaptation to specific customer requirements as outlined in the project execution plan. Custodian, project controls team. Process steps. 1. Introduction. Importance of accurate progress reporting for understanding the current status and future projections of a project in terms of schedule and cost. Engineering and design leads are responsible for providing regular and honest updates on progress. This guideline serves as a basis for progress measurement, supplemented by customer-specific requirements. Methods of progress measurement. 2.1 Earned value. Uses budgeted and earned man-hours to calculate and summarize progress. Man-hours are budgeted for activities and earned as work is completed, relating physical progress to the assigned budget. Variations in man-hours due to overruns or underruns affect the forecast value, but not the progress measurement. 2.1.1 Procedure. Assign man-hour budgets to activities. Status activities based on work performed, e.g., percentage of drawings completed. Calculate earned man-hours by applying the percentage completion to the budgeted man-hours. Use rules of credit for specific deliverables to determine physical progress. 2.1.2 Standard methods. Earned work unit method. Progress is determined by statusing activities in a project schedule weighted by budgeted man-hours. Incremental progress is measured against predefined milestones. Level of effort method. Progress is statused by dividing expended man-hours by forecasted man-hours, suitable for support activities closely related to time duration. 2.2 Standard rules. Percent complete is derived from physical progress. Budget man-hours equal the estimate plus approved changes. All budgeted items are statused for progress. Earned man-hours equal percent complete multiplied by budget man-hours. Total percent complete equals total earned man-hours divided by total budget man-hours. Progress measurement is unaffected by expenditures, forecast, or productivity. Overruns or underruns only affect forecast value. Applications include home office design disciplines, direct field labor, and subcontractors. 2.3 Other methods. Straight line method. Calculates earned value by percentage of duration. 50-50 rule. 50% of the budget is earned when the activity starts, and the remaining 50% upon completion. Nonlinear method. Allocates budget and progress in a non-proportional S-curve relationship. Milestone method earns man-hours in blocks based on predefined milestones. 3D model progress measurement. 3.1 General. Progress measurement for 3D model projects involves several steps. Establish work breakdown structure, WBS, for progress reporting. Set up progress weightings and measurable components for each discipline. Prepare progress report formats. 3.2 Measurement of progress. Input progress figures into the 3D model progress reporting program or spreadsheet. Generate progress figures by WBS and report to project controls. 3.3 Control and reporting. Progress is measured at the component level using rules of credit. Summate progress at model, discipline, and project levels. Combine measurements with subjective progress judgments from model review sessions. NASH 3.4 Preparation for 3D model progress measurement. Establish a work breakdown structure, WBS, for model progress reporting, which will vary from project to project. Set up task progress weightings and measurable components for each discipline within the 3D model. 3.4.1 Piping modeling. Measure progress by assessing each line number in the model and the percentage progress achieved based on rules of credit. Input the rules of credit percentage into the modeling software as criteria are met. Activities such as checking, reviews, clash checking, and isometric production may be included in the rules of credit. Use the 3D model progress reporting program or spreadsheet to calculate the progress for each model and overall project progress. Weighting is based on budget hours, e.g., if the task has a budget of 200 hours, the weighting is 200. NASH 3.4.2 Pipe support modeling. Measure progress by subjective assessment or by treating each support as a component. Assess the number of supports expected in the model upon completion, and the level of completion. Input progress information into the 3D Model Progress Reporting Program or spreadsheet to calculate the overall progress. 3.4.3 Equipment Modeling. Progress is based on each individual piece of equipment listed in the equipment list. Use rules of credit for each piece of equipment to determine progress. Input the rules of credit percentage into the modeling software as criteria are met. Weighting is based on budget hours, similar to piping modeling. 3.44 Structural Modeling. Progress measurement can be based on subjective assessment of each structural model or by assessing structural components within a model. Components may include primary and secondary steel, plating, grating, and handrails. Measure progress against rules of credit and input data into the 3D Model Progress Reporting Program or spreadsheet. 3.4.5 Civil Modeling. Progress can be assessed similarly to structural models, either by subjective assessment of the model or by components such as concrete foundations. Rules of credit for drainage or underground services models may be applied. Input data into the 3D Model Progress Reporting Program or spreadsheet. 3.4.6 Electrical Modeling. Measure progress of cable ladders and electrical equipment against rules of credit. Methods may include component-based measurement, equipment model rules of credit, or underground model rules. Input progress data into the 3D Model Progress Reporting Program or spreadsheet. 3.4.7 Instrumentation Modeling. Measure progress of instrumentation design against agreed rules of credit. Components may include offline tagged instruments and stands. Input data into the 3D Model Progress Reporting Program or spreadsheet. 4. Roles and responsibilities. Project Engineering and Design Group. Complete assessment and reporting of progress at the discipline level. Project Controls Group. Compile progress reports based on the information provided by the Engineering and Design Group. Project Controller. Responsible for completing summary progress reports and managing the progress measurement process. Appendices. Appendix 1, Sample Calculation. Detailed steps and examples for calculating earned man-hours and progress percentages. Appendix 2, Deliverable Types with Rules of Credit. Specific rules for various deliverable types, such as calculations, checklists, work packages, datasheets, and drawings. Appendix 3, Example Summary Progress Report. Template for summarizing progress at various levels of the project. Appendix 4, Rules of Credit for 3D models. Detailed rules for assessing progress on piping, equipment, structural, civil, electrical, and instrumentation models. Appendix 5, Sample Calculation for 3D Model Progress Measurement. Examples demonstrating progress calculations for different model types. Appendix 6, Measurable Component Types. List of measurable components for each discipline and the criteria for progress measurement. By following this structured guideline, the engineering progress measurement process will ensure accurate and comprehensive tracking of project progress, supporting effective project management and successful project outcomes.